Hi there, Algebra 2, 6.3, binomial radical expressions. Alright, objective. Students will be able to add and subtract radical expressions. Vocab. Like radicals, are radical expressions that have the same index and radicand. Combining radical expressions, sums, and differences. Use the distributed property to add or subtract like radicals. So we have a the nth root of x plus b nth root of x. So we can do a plus b, and we have nth root of x. Alright, and you can do the same thing with subtraction. The only thing is it would be a minus b. Alright, so first things first here. We have to think what we can think about out of both of these. Well, it's just like regular, we're multiplying. In this first one, I can take the square root of 5 out of both of them. So I'm going to pull that out front. Alright? And I would take, or actually be, I wonder if I typed that in wrong. I'm going to guess yes. No, I did not. Okay, just wanted to make sure. So, this one you cannot do. Because of the fact that this is a cube square root, or cube root, and this is just square root. So you cannot. Because of the fact that your indexes are different. Alright, this one we can. We can take this out of both of them. We can take the square root of xy out of both of them. We technically be like dividing these out of both of these. Which would then leave us, when we divide, we'd have 3x plus 4x. Alright, which realistically could be the square root of xy is 7x. Because now we're adding, our bases are the same, we can add those numbers in front. Okay? This one's the same thing. We have the same thing, we can pull this out of both of these. Just like if we were taking the greatest common factor out of it, well, this is our greatest common factor. The fifth root of x, or 3x to the second, is what we're pulling out of both of them. When we divide that from it, we're going to be left with 17 minus 15, which would actually get us 2, so that would get us the fifth root of 3x to the second. Making our life really, really easy. And honestly, I'm guessing this number could go back up in front, or actually I know it can go back up in front. And that's the whole purpose of this. I'm leaving it behind, but you could pull that back up front. That's why I got it in the parentheses though, is because I'm leaving it behind, but you could take that back up front. Alright. Using radical expressions. In the stained glass window design, the side of each small square is 5 inches. Find the perimeter of the window to the nearest tenth of an inch. Alright, so you technically have 5 here, you'd have 5 here. You have 5 here, you have 5 here, you'd have 5 here. Right? Let me think about that for a second. We're working with triangles here, right? How could we ever find the length of each one of these? Well, we know this is 5, I believe is what it's saying. So this is 5 because it would be the edge of the deal. So we have a 5 by 5, which means we got an isosceles triangle here. Trying to think, probably a little bit of calculus or not calculus, geometry here. So, we have 5 square root, we have a full, trying to think how this works. Okay, I believe, I think what it is when you have a 30, let's see, 45, 45, 90 prime. So you should be able to use Pythagorean theorem here. So, using Pythagorean theorem, we get 50, right? Then we gotta take the square root of 50 because we'd have a squared plus b squared, which would be both of these, equals c squared. Okay? We can take 25 out of this, that leaves us 5 square root 2. Alright, we have 2 of those. So we would actually have, times that by 2, so you're going to get 10 square root 2. Alright, this one's going to be 3 of them, so I believe that would be 15 square root 2. Alright, so now we got the length and the width. Okay? Once again, how do you find the area, or we want to find the perimeter? Well, you got 2 length plus 2 width equals P. Alright, length was 15 square root 2. So 2 times 15 square root 2. Alright, so you're going to get 30 square root 2 plus, this is going to be 10 square root 2 times 2, which is going to give me 20 square root 2. Alright. Now we have to ask ourselves, can we add those together? Well, technically, those are like having the same base because our variable, which is going to be our square root here, is going to be the same. So we get 50 square root 2. Alright, we type that into our calculator and we should get 70. Where's my calculator? 70.7 approximately. So that would be your answer. That is about what your perimeter is. Now, this had a little bit of geometry to do. Some of you do not know your geometry, so this one would be a little harder, and you'd probably have to ask me a question. But the thing you do know is you have an isosceles triangle. These two angles are the same, which I guess realistically we can know they're the same and for sure not know this is a 90-degree angle. But we also know this is a 90 because that's a square, square, square. So yes, we should know it's a 90-degree angle. Well, it should have came to my mind quicker than it did. Alright, and then you can use Pythagorean theorem, and we know how to do that. Alright, what is the simplest form of the expression? The square root of 12 plus the square root of 75 minus the square root of 3. Alright, we take this. We have 4 and 3 here, which means we have a 2 square root 3. Because we can't take the square root of 3, we can take the square root of 4 and we get 2. Here we'd probably take out 25, which would leave me 3. Square root of 25 is 5. Square root of 3 plus minus the square root of 3, which is realistically 1 square root 3. Alright, add these together because this is like having a variable in this. Obviously our variables are all the same, so we can now add these together. We get 2 plus 5, which is 7 minus 1 is 6 square root 3. Alright, what is the simplest form of the expression? The cubed root of 250, the cubed root, or plus the cubed root of 54 minus the cubed root of 16. Alright, let's start with cube root of 16. You can take 2 and 8. We can take the cube root of 8 from yesterday, which is going to be 2 cube root 2. Alright, here I'm going to go, let's go 9 and 6. Actually, we could go 27. Would probably be our best bet. 27 and 2. Cube root of 27 is 3 with a 2 left in the square root. So we got minus there. 25. We know 2 and 125 are going to go together. We remember from yesterday that is going to get us 5 cube root 2. Alright, adding. Bases are all the same, or variables all the same with this cube root 2. So that means we can add these. We get 8 minus 2 is 6. And then you got to keep your variable. There's my answer. Okay. Alright. What is the product of each radical expression? We're multiplying binomials. I would probably just go by FOILing this. We get 20. Alright, FOIL again, we're going to get plus 16 square root 2. Alright, now we're going to do inside. So we're going to get plus 10 square root 2. Then we're going to do last, which is going to get us 8 square root 4, which actually can simplify down, and it would be 16. So let's add this together. We get 10. So that'd be, we have like variables or square roots here. I think of them as variables because then I know I can add them together. I get 26 square root 2. I still have 20 here. Add them together. I should get 36 plus 26 square root 2. That should be your answer on a question like that. Alright, the next one. Exact same thing. We are going to have to do first, outer, inner, last. Okay? So, we do the first. We are going to end up getting 3 times 2, which is 6. Alright, then we're going to do outside. And unfortunately, I went through my answer. Awesome. Alright. We get plus 12 square root 5. Alright, inside plus 4 square root 5. Alright, and then we're going to go last, and we're going to get 8 plus the square root of 25 because I multiply what's in my square root, which we know that is 5, so we're going to get 5 times 4, which is 40. We can combine these because these square roots are the same, which is like saying I have like variables. So we're going to get 46 plus 16 square root 5 as our answer. Alright. What is the product? This looks very similar to what we were just doing. Okay? So, we go. And we're going to do first. We get 36. We're going to do outers. We're going to get plus 6 square root 12. We're going to do inside, which we should get negative 6 square root 12. And we're going to do outside, our last, which should get us plus or minus the square root of 144. Alright, the square root of 144 is 12. This and this are going to cancel out because one's positive and negative. So we got 36 minus 12, which would be 24. Alright, now we have first 9. Outer is going to be negative 3, square root 8. Alright. Then we are going to go inner. We're going to get positive 3, square root 8. Alright. And then we are going to have minus square root of 64. Square root of 64 is going to be 8. It's going to be negative. These two are opposite signs, and they're the same thing, so they're going to cancel out. We got 9 minus 8, which should give us 1. Alright, of course, the last and final thing is rationalizing the denominator, which is a lot of what we just did and kind of just got ready for. We want that middle to cancel out. We've done this before. Now with square roots, but with other things. Alright, so we are going to go 3 plus the square root of 6 on the bottom here, and what we do at the top, we must do to the bottom. Alright, so that's what I'm looking for a conjugate here. Here I would have to do square root of 3 plus the square root of 5. Alright, what I do to the bottom, I must do to the top. Okay, we'd have to FOIL that through. We're going to end up with 2 square root of 21 plus 2 square root 5. Oh, no, 35. Okay. 35. Alright, none of that can really be broke down. Okay, let's do the bottom. We're going to get the square root of 3. That's the square root of 3, which is the square root of 9. Alright, outer is going to get us the square root of 15. Inner is going to get us minus the square root of 15. And last is going to give me the square root of 25. Alright, so we are going to get 5 here, we're going to get 3, this is going to cancel out, this is minus, we're going to get a negative 2. So we're going to get 2 square root 21 plus 2 square root 35. Alright, we can divide each one of these by this negative 2, which is going to leave us negative square root of 21 plus, technically, a negative square root 35. That would be your answer. Alright, down here, similar thing. We distribute that through. We're going to end up getting 12x plus 4x square root 6. Alright, down here, we're going to get 9 when we do first. When we do outside, we're going to get plus 3 square root 6. Then when we do inside, we're going to get minus 3 square root 6. And then when we do the last, we're going to get the square root of 36. Alright, this is going to cancel. This is going to get me 6. So we're going to end up with 12x plus 4x square root 6 plus, or over. And that looks like it's going to be 3. That would be our final answer. There is your homework.